All right, let's jump right in. Today we're going to tackle a real classic, a computer science puzzle that's so satisfying because the solution is just, well, it's elegant. And it's hiding right there in plain sight. So picture this. You've got a list of numbers, and it's already sorted, which is nice. But it's messy. It's full of duplicates. Your job, clean it up. But here's the catch, and it's a big one. You have to do it in place. And what does that mean? It means no making a new, shiny, clean list on the side. You've got to work with what you've got.
And, this isn't just some tricky little brain teaser they ask in interviews, though they definitely do. This is a super practical problem. It pops up all the time when you're trying to save memory, make your code run faster. It's all about being clever and resourceful.
Okay, so let's get our hands dirty. Here's our starting point. You can see it right there. Sorted, but loaded with repeats. Lots of zeros, ones, and twos. The goal is to transform this very same array so it starts with just the unique numbers, 0, 1, 2, 3, 4, all neatly packed at the front. So how on earth do we do that? The secret? It's a really cool technique called, simply enough, the two-pointer solution. And once you see this pattern, you'll start seeing it everywhere. It's just so powerful for these kinds of problems. So what are we talking about here? It's actually pretty intuitive. Imagine you're using two fingers to trace through your list. These pointers are just variables keeping track of where you are. And here's the key. They don't have to move together. One can race ahead while the other one kind of hangs back, letting us do everything we need in just one single super efficient pass.
All right, to really make this click, let's give our two pointers some jobs, some personalities. We'll call the first pointer I, the builder. The builder's job is to construct the clean, finished part of the list. It's careful. It only moves when it has a new, unique number to write down. Then we have pointer J, the scout. The scout is the explorer. It's always on the move, running ahead through the array, looking for that next unique number to bring back to the builder.
Okay, theory's great, but let's see it in action. It's time to watch our little team, the builder and the scout, clean up this array step by step.
Okay, here we go. Initial state. Our builder, I, starts right at the beginning, at index 0. The scout, J, starts one step ahead at index 1. First thing we do? Compare. The builder's looking at a 0. The scout's also looking at a 0. Uh-oh, they're the same. That's a duplicate.
So because they found a duplicate, the builder has nothing new to build. It just stays put. Its job is to wait for unique stuff. The scout, on the other hand, its job is to explore, so it moves on. It slides over to index 2, still looking for something new, something different. Aha, pay dirt. Just a moment ago, our scout found a 1, which is different from the builder's 0. So what happens? First, the builder moves up one spot to index 1. Then it copies the scout's discovery. Boom! The array is now 0, 1, etc. See, our clean section is growing. Now, the scout has also moved ahead and, well, look at that. The builder is on a 1 and the scout is also on a 1. We found another duplicate. And from here, you can probably see the pattern, right? This little dance just repeats. The scout is going to keep running ahead, skipping over all those other ones because they're just more duplicates. And all this time, our builder just waits patiently. It's not going to move an inch until the scout finally yells back, "Hey, I found a 2." That's when the builder will spring into action again. Okay, let's fast forward to the end. The scout has run all the way to the end of the list. And look at our array now. The builder, I, finished its journey at index 4. This means the first part of the array, from index 0 to 4, is our perfectly clean, unique list. 0, 1, 2, 3, 4. And all that other stuff at the end? Who cares? It's just junk left over from the process. Our work is done. The important stuff is at the front. So what does the function actually return? It returns the number of unique items. And how do we know that? It's just the builder's final position plus 1. So it ended at index 4, which means we have 5 unique elements. That's it. So, okay, it works. We proved it. But why is this solution so celebrated? Why is it considered so elegant? Well, it all comes down to how incredibly efficient it is. Let's break down why this method totally wins. First up, speed. Programmers call this O of n, time complexity. which is just a fancy way of saying it's really, really fast. It means that if your list gets twice as long, the process only takes about twice as long to run. That's because our Scout just makes one single trip through the list. That's it. One pass, no going back, no complicated loops inside of loops, just a clean sweep. And then there's the memory usage. This is just as crucial. It's called O1 space complexity. All that means is that it uses a tiny, constant amount of extra memory, basically for our 2 pointers. And that's it. It doesn't matter if the list has 10 numbers or 10 million. And this is the whole point, right? This is what we set out to do. No new array. All the work was done in place. But what about the weird cases, the edge cases? A good algorithm has to handle those too. And this one does beautifully. What if you give it an empty list? It handles it. What if the list is already unique with no duplicates? No problem, it doesn't mess it up. What if it's all duplicates? Yep, it correctly boils it down to just one. It's just solid. It's reliable. So if we zoom out for a second, this little puzzle and its solution teach us something really important about how to think like a programmer. It really boils down to this philosophy. The best solution isn't always the most complicated one. Real elegance is about finding the simplest, most direct way to solve a problem with exactly the tools you have, and nothing more. This 2-pointer approach is a perfect example of that.
And that's the big takeaway here. This Scout and Builder model, this idea, it's not just for this one problem. It's a powerful pattern. It's a tool for your mental toolbox. So the next time you're faced with a messy list you need to filter or search or organize, just ask yourself, wait a minute, could a Scout and a Builder solve this? You'd be surprised how often the answer is yes.